Assalamu alaikum students, hope you are all fine. Today's our topic is application of derivative. It is your third chapter in calculus book. You can see it here right now. It is your here application of the derivatives. Now first we will start with the topic extrema of functions. Extrema of function is we define a function f on an interval I and we say we are taking 2 points x1 and x2 from this interval I and we say f is increasing on I if f of x1 is less than f of x2 whenever x1 is less than x2. As you can see in the diagram, here we have x1 point and here we have x2 point. Now f of x1 is attaining minimum value at the point x1 and it is attaining maximum value at the point x2. So here function is increasing from x1 to x2. Then we define f is decreasing on interval I if f of x1 is greater than f of x2 whenever x1 is less than x2. Now here we will have the decreasing function where x1 at the point x1 the function is attaining maximum value and at the point x2 function is attaining minimum value. So the function is decreasing from x1 to x2. Then we say f is a constant on interval I if f of x1 is equals to f of x2 for every x1 and x2. In this case x1 and at the point x2 the functions have same values. F of x1 is equal to f of x2. So this is your constant function. Then we have another definition. Let a function f be defined on a set S of real number and let C be a number in S. Here we have any number C and at that point f of C is the maximum value of f on S if f of x is less than or equals to f of C for every x in S. As you can see in this diagram, the function is attaining maximum value here. It is the topmost point of the function. Now at this point x is less than c and f of c is the maximum value of the function, and here you can see that c is less than x but f of c is the maximum value at this point. So here f of c is the maximum value of the function. Now here you can see that f of x and f of c is equal. So in this case, the maximum value is f of c. Now we have minimum value of f of c. F of c is the minimum value of f on S if f of x is greater than or equals to f of c for every x in the domain. Now here you can see that f of c is the minimum value here and f of x is greater than or equals to f of x. C is less than x and in this case c is greater than x but f of c is the minimum value here and f of x is maximum value of the function. Now maximum and minimum values are sometimes called extreme value or extrema of the function. The other point is if f is a constant function then f of c is both maximum and minimum value of for every real number c. In constant function f of c is both your maximum value and minimum value. So now we will explain this with the help of example. We have function 4 minus x square. Find the extrema of f on the following interval. We have been given different interval. The first one is your closed interval minus 2 and 1 in which the endpoints are included in the interval. The next one is your open interval minus 2 and 1 and the C interval is your half open half interval in which one is from one side it is open and from other side it is closed. and the D1 is in which it is open interval 1 and 2. The first one step of the question is that we have to draw graph of the function. For graph of the function, we will have a table for each value. We will define this table from -2 to 2. It will attain 0 at point -2. Minus at point -1 it is 3. For 0 it is 4. For 1 it is 3. And for 2 it is 0. So we will plot this value on the diagram. It will give you a parabolic shape. You can see it. It is a parabolic shape. Now, the first one interval -2 and 1. It is from -2 and 1. And these dark circles shows you that these endpoints are included in the interval. So this graph is from -2 to 1. Now for this diagram, maximum value is at 0. It is your 4. And minimum value is at point -2. It is 0. Now in part B, we have open interval -2 and 1. And here we will show these endpoints with hollow circle. It means -2 and 1 are not included in this domain. Now the maximum value of the function is at point 0. It is your 4. But minimum value is not included. So it has no minimum value. So because -2 is not included in the domain. Now C part is 1 and 2. Now here at the point 1 it is hollow circle, so it is not included in the domain, but at the point 2 it is included. Now you can see there is no maximum value of the function, but minimum value is at point 2, which is 0. Now we have D part, which is open interval 1 and 2. So there is no maximum value and no minimum value because 1 and 2 are not included in the interval. Now you have an assignment, which is we have a function f of x is equals to 1 over x square. Find the extrema of f on these two intervals. First one is your closed interval and the second one is your half open, half closed interval. Now next is our extreme value theorem. In extreme value theorem, if a function f is continuous on a closed interval ab, then f takes on a minimum value and a maximum value at least once in the interval. Mean every function which is continuous, it must attain maximum value and minimum value at least in the interval. So we have another definition, local maximum and minimum. F of c is a local maximum of f if there exists an open interval ab containing c such that f of x is less than or equals to f of c for every x in the interval, that is in the domain of f. Mean it is local maximum if f of x is less than or equals to f of c. The second one point is this f of c is called local minimum of f if there exists an open interval ab containing c such that f of x is greater than or equals to f of c for every x in the domain of f. Third one point is each local maximum and minimum is called local extremum of f, and the totality of such numbers are called local extrema of f. Then we have another theorem which is very important for your exercise. If a function f has a local extremum at a number c in an open interval, then either f prime of c is 0, mean that the derivative of the function at point c is 0, or derivative of the function does not exist. We have 2 points according to this theorem. If f prime of c exists and f prime of c is not equal to 0, then f of c is not a local extremum of the function f. Sometimes the derivative exists, but this derivative is not equals to 0. then in this case local extremum of the function does not exist. Then we have another point, critical number. A number c in the domain of a function f is a critical number of f if either f prime of c is 0 or f prime of c does not exist. Then we have certain guideline for finding the extrema of a continuous function. The first one guideline is find all the critical number of the function in interval. Calculate f prime of c. It is your f prime of c. Calculate f prime of c for each critical number c found in guideline 1. Then another point is calculate the endpoint values f of a and f of b. It can be your maximum or minimum value. The maximum and minimum value of the function on interval are largest and smallest function value calculated in guideline 1 and 2. We will use these guidelines in this example to find maximum and minimum values of the function. Here we have been given the function f of x, which is equals to x cube minus 12 of x, and the interval is given minus 3 and 5. We have to sketch the graph of the function and find maximum and minimum values of the function. Here we find first one f prime of x. F prime of x is equals to 3x square minus 12. Here we will simplify this derivative. It is equals to 3 times x minus 2, x plus 2. Now put f prime of x is equal to 0. It will be 3 times x minus 2, x plus 2 is equals to 0. Since derivative exists for every x, the only critical number are those for which the derivative is 0, that is minus 2 and 2. Since f of x is a polynomial, so it is continuous on minus 3 and 5. Now we will first draw the graph of the function, for which we need a table. This table have the value from minus 3 and 5. You will calculate the values according to these points and plot these values on the graph. Here you can see that maximum value is at the point 5, which is 65, and minimum value is at point 2, which is your minus 16. So you will find the maximum value or minimum value, first one for critical point, then for end point of the interval. End point of the interval are minus 3 and 5. So we will obtain maximum and minimum value here. Now the minimum value of the function is the smallest function value, which is minus 16, and the maximum value is the endpoint extremum f5 is 65. And we have another point here. The tangent line is horizontal at the point corresponding to each of the critical number minus 2 and 2. As we have also studied this point, that the tangent line is always horizontal when the derivative, we are putting the derivative of the function equal to 0. Here you can see that these are the tangent line which are horizontal. Then we have the exercise 3.1. From exercise 5 to 6 is sketch the graph of f and find the extrema on each interval. Here we have been given a function 1 by 2 x square minus 2x, and we have been given different intervals. Now first step is that we have to draw the diagram of the function, for which we will take values from 0 to 5, and according to these values we will calculate the function value and we will draw the diagram of the function. You can see it is a parabolic shape. Now here the first one point is the 0, 5. It is half open, half closed interval. At point 0 it is your closed interval, but at point 5 it is open. Now the maximum value is none and minimum value is at point 2, which is minus 2. Then we have B part is 0 to 2 open interval. It is from 0 to 2. It is your open interval. So here we have no maximum value or no minimum value. The third one is 0, 4. It is your open interval, and here we have only minimum value which is at point 2 and maximum value is none. At point D, it is from 2 to 5. It is closed interval. So maximum value is at point 5 is 2.5. But minimum value is at point 2 which is minus 2. Now you have the exercise 3.1. Thank you student. I will show you. I will also give you the PDF of this lecture. Okay student. Allah Hafiz.